So a ton of engineers are out there building some absolutely incredible things with AI. But here's the catch. A lot of the time they're using APIs they don't really control or maybe don't even fully understand. So in this explainer, we're going to pull back the curtain and show you how modern AI actually works.
You're probably using these powerful tools all the time, right? For work, for brainstorming, just to plan out your day. But have you ever really stopped and wondered what is actually going on inside that black box? What really makes it all tick?
Well, here's the big secret. It's not magic. It's not some unknowable force. Modern AI systems are built on a stack of components, infrastructure that you can totally understand. And by the end of this, you're going to have a really clear picture of how all those pieces fit together. All right, let's get into it. Okay, so everything, and I mean everything, starts with how an AI understands meaning. We're not just talking about words, but the actual intent behind them. And this whole foundation is built on a concept called embeddings. So what is an embedding? When you strip it all down, it's really just a list of numbers, a vector. But here's what's so crucial. That list of numbers represents the semantic meaning of something. It could be a piece of text, an image, you name it.
And this is where you really see the power of embeddings. A normal keyword search is super rigid, right? It's looking for the exact phrase, "write project report." But a semantic search, using embeddings, gets that draft team summary means pretty much the same thing. In this kind of high-dimensional map of meaning, things that are close together are similar. This is the foundation for, well, everything else.
Okay, cool. So we've got these incredible embeddings that capture meaning. But where do you put them? Where do you store them so the AI can actually use them? And that brings us to our next piece of the puzzle. And that's where vector databases come into play. The easiest way to think about one is as the long-term memory for an AI. It's the place where all that meaning we just captured gets stored and organized, ready to be recalled in an instant.
So how does this memory work? Well, it's not storing data in typical rows and columns. It's storing our embeddings. And its superpower, its whole reason for being, is something called similarity search. When you ask a question, it zips your query into an embedding, and then, in milliseconds, it finds the vectors in its memory that are the closest match in meaning. This is what makes an AI feel like it's pulling up the exact right detail at the perfect time. And it's systems like Pinecone, Weaviate, and Milvis that are doing all this heavy lifting in the background.
All right, so having a memory is great, but it's not enough, right? The AI also needs a brain, a way to decide what to do with all that information. And that, my friends, is agent orchestration. This brings us to the idea of an AI agent. And I want to be clear, an agent is way more than just a chatbot. It's a system that's designed to perceive what you want, reason through the steps it needs to take to get it done, and then actually act on it using whatever tools it has available. And this example just lays it all out perfectly. You give it a complex command like this, and the agent orchestrates the whole thing. It gets what you want, it plans out the steps, then it acts. It goes to its memory, the vector database, pulls the data, writes the summary, and then calls an outside tool, like an email API, to finish the job. This reason and act loop is what turns a simple tool into a real partner. Okay, but here's a huge problem with even the biggest, baddest AI models out there. They only know what they were trained on, which could be months or even years old. So how do you connect them to your specific, up-to-the-minute information? The answer to that problem is a technique called retrieval augmented generation, or RAG for short. You can think of it as the bridge that connects a huge general-purpose model to your own private knowledge base. It's what grounds the AI's answers in reality.
So let's break down how this actually works, step by step. Let's say you ask about action items from a recent meeting. The RAG system kicks in. First, it turns your question into an embedding. Then, it searches the vector database for the most relevant documents, in this case, your meeting notes. Then, it feeds only those notes to the language model as context. Finally, the model generates its answer based only on the info you just gave it.
And this is the #1 reason RAG is such a game changer. It massively cuts down on AI hallucinations. See, the model isn't just guessing anymore, or trying to pull something from its massive, generic training data. It is literally working with the real, specific facts you just handed it. And that makes its answers way, way more accurate and trustworthy.
All right, let's talk about one of the biggest headaches in building these systems, integration. How does your AI assistant connect to your calendar, your email, your CRM? Right now, it's a mess of custom code. But a new standard is aiming to fix all that.
It's called the Model Context Protocol, or MCP. And honestly, the best way to think about it is this. It's like a USB-C port for AI. a single, universal standard for plugging anything and everything in.
So imagine this. Instead of needing to build a custom one-off connector for every single app, MCP provides one universal way for an AI agent to find and use any tool or data source. This means the AI assistants of the future won't be trapped inside one company's little walled garden. They'll be able to securely plug into all the services you already use, making them so much more useful. So we've just walked through this amazing, powerful AI stack, but this leads us to a pretty serious and frankly often ignored question. Who actually controls all of this infrastructure?
You see, for most people building with AI today, the answer is someone else. They're using OpenAI for embeddings, Pinecone for their vector database, Google for their model calls. And as you can see here, that's a trade-off. You get convenience, but you give up control, you share your data, and your uptime is totally dependent on them. The other path, self-hosting, gives you all that control and privacy back, but it comes with a much higher cost and a lot more complexity.
And this quote right here just says it all. When any of those goes down, your product goes down with it. You have zero control. When you rely completely on third-party APIs, you're introducing a massive, single point of failure into your system.
Okay, so let's just quickly run back through the 5 building blocks we covered, the core components of a modern AI brain. We had embeddings, the language of meaning; vector databases, the AI's long-term memory; agent orchestration, the decision-making brain; RAG, the bridge that grounds AI in reality; and finally, MCP, the universal connector.
And really, when you boil it all down, it comes back to one simple but really powerful idea. Modern AI is not magic. It is infrastructure. And just like any other critical infrastructure, it has to be designed for resilience, for ownership, and for security, right from the very beginning. So, I'm going to leave you with this to chew on. The AI stack you're building, or the one you're using every day, is incredibly powerful. There's no doubt about that. But is it resilient? And maybe more importantly, who's actually holding the keys? It's a question we all need to be asking. Thanks for tuning in.